You can see the Great Wall of China from space. That line sounds confident and irresistible. Today we test it. We'll ask what counts as space, how eyes actually resolve detail, and why contrast and thickness beat sheer length. In everyday talk, space usually means low Earth orbit. That is the zone a few hundred kilometers up where astronauts on the International Space Station circle Earth. From that height, your eyes face a hard limit. Human vision can resolve details down to about 1 arc-minute, which translates to roughly 100 meters at ISS distance. The Great Wall is long, but it's narrow. Most sections are only a few to several meters wide, with colors close to the land around them. Length seduces us. A line that stretches across provinces must be obvious, right? Here's the core idea. Visibility from orbit depends far more on contrast and line thickness than on length. Contrast means how strongly an object stands out from its background. Line thickness is simply how wide that object appears from your vantage point. A thin line with faint contrast disappears faster than a shorter, bolder shape. That principle rules the view from low Earth orbit. The myth spread because it flatters our sense of scale. The wall feels colossal in history, so our brains project that feeling onto eyesight. It also spread because textbooks and travel lore love simple superlatives. Only human-made structure visible from space sounds cleaner than rarely visible under special lighting with optics. Media patterns reinforced it. Telephoto images and cropped frames looked like proof, and few people asked whether a lens had done the heavy lifting. Telephoto lenses use a long focal length to magnify distant scenes. They can turn thin lines into clear stripes, even when your unaided eyes would see nothing. Astronaut photos often rely on telephoto lenses. When those images circulate without context, viewers assume a naked eye view that didn't happen. Now the evidence, step by step. First, the mechanism of human vision sets a size threshold near 100 meters at ISS altitude. That threshold isn't a sharp cliff, but it's a firm guide. Objects much thinner than that must rely on strong contrast or aligned shadows to be seen. The wall's width falls an order of magnitude below that guide. A feature 5 to 10 meters wide just doesn't strike the retina with enough thickness. Second, atmosphere matters. Even from orbit, you still look through layers of haze, dust, and moisture that scatter light and wash out edges. That scattering kills contrast. A pale wall against pale soil fades into the landscape, especially at noon when shadows flatten. Third, lighting and angle decide a lot. When the sun sits high, the wall casts short shadows and blends. When the sun sits low, shadows stretch and help. But help is not a guarantee. The shadow must align with your viewing angle to thicken the apparent line, and that alignment changes quickly as the station moves. Fourth, counterexamples teach the rule. Wide runways, bright salt flats, and geometric farm patterns often pop out because they offer both width and contrast. Cities at night blaze with lights. You can spot them easily, which tricks some into thinking any famous structure should also shine through. But the wall is not a continuous light source. Fifth, replications clarify the myth. Many astronauts have said they could not see the wall unaided. A few reported brief, uncertain glimpses under snow or dust when contrast improved. Those rare moments do not overturn the rule. They prove it by exception. When contrast spikes, odds rise, but the basic width problem remains. Think of a hair across a schoolyard. A hair might be a meter long, but from far away it vanishes because it's too thin against the ground. The wall is like that hair on a continental scale. Immense length, minimal width. We also confuse correlation with causation here. The wall's fame correlates with the claim, but fame doesn't cause visibility. Thickness and contrast do. What about those dramatic photos labeled Great Wall from Space? Most were shot with powerful zoom or processed to boost edges and tones. The camera did the work. Your naked eye did not. Another source of confusion comes from altitude. Some aircraft fly at about 10 to 12 kilometers, where a trained observer with binoculars might spot certain segments under snow. But that's not orbit. Low Earth orbit is 20 to 40 times higher, which multiplies the resolution challenge. You might ask whether desert dust helps. Sometimes it does, because dust can coat the wall differently than the surrounding ground and gently boost contrast. Snow helps more. A dark stone line on white snow acts like ink on paper, thickening the apparent stroke and making rare sightings possible. Still, rare and aided is not easily visible. The original claim sets the bar low and wide, and the evidence doesn't clear it. Another strong alternative explanation says, maybe the wall is visible because it's on ridge lines. Ridges naturally create contrast, so perhaps the wall rides that advantage. Ridges do help your eyes find patterns, but even then, what you likely see is the ridge line itself. not the narrow masonry on it, unless snow or shadow amplifies the wall's edge. Lighting cycles quickly in orbit. Astronauts get a sunrise or sunset every 90 minutes, which means favorable angles flash by and vanish. Even if a segment pops for a moment, the window closes fast. That doesn't add up to easily visible. Now a compact uncertainty check. Reports vary among observers, and memory under extreme conditions can be unreliable. Some astronauts say yes in special cases, others say no, and the mix leaves a small margin for debate. But the central physics does not wobble. The wall's narrow width and low contrast dominate the outcome almost all the time. Here's the practical rule of thumb. When judging whether something is visible from far away, ask 3 quick questions. How thick is the line? How strong is the contrast? And what is the viewing angle? If any one answer is weak, assume the view will disappoint. If 2 are weak, write it off unless conditions are extraordinary. Apply that rule beyond space. It works for spotting trails from a mountain, ships on a hazy sea, or buildings from a plane window. It also guards your reasoning. Big things are not automatically visible. Visibility follows optics, not reputation. So where do we land on the myth? The Great Wall of China is not easily visible to the naked eye from space, and under normal conditions it's effectively invisible from low Earth orbit. Telephoto lenses and lucky snow can create exceptions. They don't rewrite the rule and they don't convert a hard-to-see line into an easy landmark. In short, scale without contrast fools us. Our perception loves grand stories. Our eyes obey simple geometry and light. Hold on to that difference. When scale meets low contrast, belief races ahead and perception falls behind. If that takeaway sticks, you'll notice myths shrinking as optics expand. That's a good trade for clearer thinking. The distilled line is simple. Visibility comes from contrast and thickness, not from fame or length. Subscribe for more myth versus reality and tell us which beloved claim we should test next.